Okay, so let's start with number 1. We'll go ahead and start with number 1. On number 1, we have 2x plus 5 equals 41. Now, I know some of you guys are probably still using that bubble diagram, which is fine. My dog is whining already. So, Sapphire wants to play fetch, so let's go ahead and take a pause. Okay, back to solving the problem. Okay, so, alright, so bubble diagram is fine, but we really need to start applying the bubble diagram into our actual two-step equation. So, first we were introducing last week was we're going to go ahead and put a line through that equation because we're going to split up the two sides. Our equation is our middle ground, and now I have two sides. I need to separate my variable side and my constant side. So I see variable on one side. So I'm going to go right here on my left, mark it, that's my variable side. So this is where only my variables can be, and I need to isolate that variable. And my other side is my constant side. So all my constants, all my numbers that are without a letter are going to go on to my right side. So what doesn't belong? Well, I see here a positive 5 does not belong on my variable side. So I'm going to get rid of that. So what's the inverse of positive 5? It is negative 5 minus 5. What we do on one side, we do on the other. Alright, so now I have 2x equals 41 minus 5 is positive 36. Positive 36. I need you guys to get in the habit of saying positive or negative. And then I'm looking on my variable side. Do I still see any numbers that I still need to get rid of? Oh, right here, this 2. I need to get rid of that 2. It's being multiplied to x, so the inverse of multiplying is divide. So we're going to divide by 2. What we do on one side, we do on the other. We're going to divide it by positive 2. And so then we're left with x equals, and 36 divided by 2, so half of 36, I believe, is 18. Positive 18. There's our answer. Alright, let's look at number 6. Number 6. Alright, I'm going to go ahead and put a line through my equation. Alright, I still see variable on my right side, so here's my variable side and here's my constant side. So this is what Miss Washington is going to be looking for. Are you writing down my steps? Are you labeling both sides of my equations that I have given you? And if you are, you get a sticker. Alright, so my left side is my variable side, so I see this negative 42. Let's get that out of there. Negative 42 doesn't belong on the variable side. So we're going to go, alright, the inverse of negative 42 is a positive 42. What we do on one side, we do on the other, positive 42. So now we're left with 9x equals 63, positive 63. Alright, I still see a number on the variable side. We got to get rid of that. We got to get rid of that positive 9. It's being multiplied, so we're going to divide by positive 9. What we do on one side, we do on the other. And then x equals, 9 can go into 63 7 times. So we have positive 7. There you go. X equals positive 7. And really that's all I really need you to do for these problems. Sapphire, you need to play fetch again? Okay. I guess we'll take another little break. So where was I? Yes. More math problems, right? It's not the end of the class yet. So yeah, that's really what I need you to do is those for a few of these different, so page 1, page 2, I'll do one more problem to help you do the first page of the packet. So let's look at number, let's look at number 7. Alright, number 7, we'll go ahead, put a line down. And a variable is on the left side. So variable on the left side, constant on the right. Now, just because we've been working with variables on the left-hand side, it does not always mean it will always be on the left-hand side. It just, right now, I've kept it very simple for you guys. This worksheet had kept it very simple for you guys, honestly. I would not have. But variable is on the left side because we see the variable is already the only thing on one side. So now I'm going to see here, I got a positive 22. We need to get that on out of there. Positive 22 is not a variable. It's a constant. Let's get it on the constant side. Opposite of adding 22, it's minus 22. So we're going to subtract negative 22. We're going to bring 5x down. So we got 5, 4. We have positive 45 left over. And when you're doing integers, think of money. Think of, okay, I have $67. I just spent $22. How much money do I have left? I have $45 left. So now I still see a number. I need to get this number out because that's not a variable. It is being multiplied to the variable. So the inverse is to divide. What we do on one side, we do on the other. So x is equal, 5 goes into 45, 9 times, so we have positive 9. That is our final answer. Okay, so of course I had to throw in some word problems because what kind of math teacher would I be if I didn't have word problems for you guys? So I know many of you guys will read a problem. You guys can dissect the problem. And you may not actually put it into an actual two-step equation. This is a two-step equation word problem, but let's just see how we can break it down and solve the best that we can based on analyzing it. So, of course, the first thing that we need to do is annotate what we see in the word problem, and then figure out first, what is it asking us to solve for? So, I'm going to get my little highlighter. And here, Emma is collecting sea glass from the beach. Yeah. That's my husband. So Emma here is collecting sea glass from the beach. She begins with 16 pieces. 16 pieces she begins with, and adds 2 new pieces per day. Adds 2 new pieces per day. How many days will Emma take to have 60 pieces of sea glass in her collection? So how many days is it going to take? So we need to find out how many days. So let's hear days, and we can substitute days for D. So we know she begins with 16 pieces and adds 2 new pieces per day. So the total that we need to end up with is 60. So I'm going to have equals 60 pieces on the right side of the equation. And I have 16 to start, and then we're going to add 2 new pieces per day, so every new day we have 2 pieces. So I know that we're going to times 2 pieces for every day. We just don't know how many days it's going to take. So I need to isolate the D. So based on this setup, I'm going to put in separated. I got my variable on my left side, and my constants are going to be on my right side. I see a positive 16. We got to get rid of that. So negative 16 minus 16 on both sides. Now I got 2D equals 60 minus 16. Looks like we got 44. And then we still have this 2 over here being multiplied to the variable. So let's divide it by 2, divide by 2. So now we have D equals 22, so that means days. We're going to have 22 days to take to get up to 60 pieces. Let's try one more. All right, let's look at number 3. Felipe bought some hats on Monday. So, Monday he bought hats. On Tuesday, he bought 5 hats more. That's kind of a weird sentence. I would have said 5 more hats, but 5 hats more. And then on Wednesday, half of the total number of hats that he had was destroyed. And he was left with 17 hats. How many hats did he buy on Monday? So we got to figure out how many hats he bought on Monday. So Monday is right here, and I'm going to substitute Monday with my variable m. And I know we're going to equal 17 total is our total. That's what he ends with. So it's going to be whatever expression is going to end in 17. So we have Monday. We don't know how many hats he bought on Monday. So we have Monday. And then Tuesday, he bought 5 hats more than what was on Monday. So Monday, and then we're going to add 5. He bought 5 more hats. And then on Wednesday, half of the total number of hats he had was destroyed. So we know that out of these total, half is destroyed. Will equal 17 left over. So let's see if this is the correct setup. So, well, I have it set up where m, so we have our Monday plus the Tuesday, which we had 5 more hats, and then we know half of it's going to be destroyed, and then we're left with 17. So, I have 2 being divided. That is a constant. I need to get rid of that. So I have my 2 sides. I have my variable on the left side, constant on the right side. Here I need to multiply by 2. What we do on one side, we do on the other. So these cancels out, and we're left with m plus 5 equals 17 times 2, 14, 34, and then minus, we have a positive 5, so minus 5 on both sides. So then m equals 29. It looks like Felipe bought 29 hats on Monday. So if we read this problem, if he bought 29 hats on Monday, and then Tuesday he bought 5 more hats than that, so then that gave us our 34. Well, out of the 34, half of those got destroyed, which would give us 17. So 29 hats. There you go. Simple as pie. All right, so that should help you throughout the rest of the worksheets. But if you do have questions, you could send me a message, private comments in the Google Classroom, because I'll be putting this in Google Classroom because these assignments are graded.